Hey everybody, welcome to this session of our chapter review for Chapter 4142, Chapter 6162. This part will take care of the first three problems. So as we're getting into our problems here, for the first one, there are some we expect you to know very well and sort of quote-unquote have memorized. But for most of us, memorization is an issue, and it also takes up a bit more brain space and time. So here's a suggestion for these first couple. We do need to know how to work with the 45, 45, 90 triangle, so make yourself a sketch over here of that type of a triangle. We also want to be able to work with conveniently and efficiently a 30, 60, 90 triangle, so we should also have a picture of those. And we do want to at least remember the special connection between side lengths. We know that if we have a side length on my isosceles right here of 6 and 6, you can either use Pythagoras and write in simplest form, or remember simply that this longer side is square root of 2 times longer than either of the other two. In a similar fashion for the 30, 60, 90, we should remember very clearly that the shortest side is always exactly half of the longest. So if I just kind of randomly pick a number there that's even for the hypotenuse, immediately I know that the 5 will be the short side length. There's always that connection. And lastly, the other side you could find by Pythagoras if you forget. Otherwise, of course, it is the short side length times the square root of 3, as many of us realize. Now, we can actually do the problems here, 1, 2, and 3, if we have this information in mind. So for the tangent of a 30-degree angle, I want to start at my 30-degree corner. I'll go back to my picture here. And the tangent, of course, is made up of the opposite over the adjacent. So I'm looking to set up the fraction opposite over adjacent. So the opposite number is, of course, the 5. The lower number, the adjacent number, by the way, is the one down below this one here. So this is our fraction. Now this isn't in simplest form, I think, as you realize. We do have to manipulate this radical on the bottom by multiplying both top and bottom by that value. As it turns out, then this bottom portion here that I'm underlining becomes actually square root of 9 or regular 3. And we have a 5 down below as part of the multiplication of those two. Up above we have 5 square root of 3. And of course, lowest terms version we're always interested in here. So final answer would become square root of 3 over 3 after performing our division by 5. This value will always be the tangent of a 30-degree angle. Actually, as it turns out, if you have a look back at the problem, we could have at the very beginning simplified and had 1 over basically just the square root of 3 to manipulate. And if you think about the multiplication by radical 3 process, that will also generate the final answer of square root of 3 over 3. For the sine of 45, similar fashion. Pick one of your 45-degree corners to begin with. I'll just grab this one here. And the sine, of course, is the opposite over the hypotenuse. So I've got 6 then over 6 radical 2. And once again, we see the process where we could simplify before we even begin. And then the process of multiplying by the appropriate square root and in simplest form. So for the sine of a 45-degree angle, it will always and forever be the value square root of 2 over 2. That is the exact value. You could double check this if you'd like on a calculator. Of course, if you type in the sine of 45, it'll give you a decimal. If you also type in square root of 2 divided by 2, that should match that decimal digit for digit. Lastly, number 3, the secant. Remember, if you read this word secant backwards, it looks pretty much like cosine. The secant is matched up with the cosine. It happens to be the flip over of the cosine. So what we would like to do, let's erase some of this previous work, make some room here. Don't need this triangle up here anymore for this particular problem. Okay, so we want to find the cosine and then flip it over. Or you could simply, as you're setting up your fraction, do the flip over immediately. I'll find the cosine first, then flip it over. So again, 30 degrees is our starting corner. Cosine, of course, is adjacent over hypotenuse. Oops, that number went away. What was that, a 10? So it looks like the first value here I'm going to write will be the 5 radical 3 over 10. And again, I could reduce that immediately to square root of 3 over 2. But we weren't interested in the cosine, we wanted the secant, so let's flip this upside down. 2 over square root of 3, and there's that pesky problem of having a radical in the denominator. As before, simply multiply by that same value. You don't have to multiply by any other digit you have below, just by the radical. So it looks like in the final analysis here, our final answer should be, let's write it over here in the space, 2 square root of 3 over 3. There you go. There's problem 1. Whew, took us a bit. All right, let's move on. Let's slide our page up here so we have some room. Since we're working with right triangles, your go-to method is Pythagorean theorem and using sine cosecant or SOHCAHTOA. So if we look at our triangle here, we've got to solve for one missing side, and we've got to get the other angles. By the way, once we get either angle C or T, we can find the other guy by subtraction of the 90 and the one we find from 180. So job 1, I'm thinking here, let's go after T first, and let's set up the Pythagorean theorem as we are used to. And if you take a moment to solve that, you will find out that T happens to equal a whole value, in this case the number 5. And this might be a Pythagorean triple that you recognize. That would save you actually doing the Pythagorean work if you recognize that triple, like the other famous one, 3, 4, 5. Next job is to figure out which angle we want, and here you get to pick which one you want to go after. I'm going to go after angle T. And I need to figure out which trig function I need to use. Now, since we have all 3 numbers, I can pick any one that I want. So I'm just going to use the sine of this one. And if I set up that fraction, sine, of course, is opposite, or 5, over hypotenuse 13. Had you chosen the cosine, you could have used 12 over 13 as your fraction, or the tangent of t, 5 over 12. Each of these 3 would get you the very same answer. Now notice here we're looking for an angle. We have a trig ratio. This is a case where you want to involve the inverse sine, and this is how we kind of go backwards from the trig ratio, and we can type this now directly into our calculator. Inverse sine of 5/13. And as I calculate that, I get about 22.6 degrees. And that was for angle T, so let's record that answer here. And then simply add that value plus 90, enter. I get about 112, and then I go 180, take away answer, and I get about 67.4. I could have also found that by doing the same process here that I did with angle T, setting up the sine or the cos or the tan of that angle, and using the fraction value based on the labeling of my triangle. But that would be unnecessary and extra work. The answers will match, though. Last one here, I think this is the top of your next page. Again, notice in the picture is a right triangle. SOHCAHTOA will be involved. You may, if you wish to, it looks like they're asking us here, to find up at angle A. So if you subtract 90 and 35 from, find my answer sheet here, from 180, you will end up getting a 55 for angle A. And now solving for, I'll just pick side A I want to find. Notice that is, in regards to the 35-degree angle, adjacent. And I do have a value for the opposite across the way. So it looks like here tangent would be the appropriate trig function to use. Notice I wouldn't use sine or cosine because I have no value, trying to make a question mark out here. I have no value for c, so I cannot use one of the trig functions that involves the hypotenuse. Tangent of that angle is 30 over a. And to make life easy for solving this one, if you write the tan of 35 over 1, you've just set up a proportion, which we all know we can solve by cross-multiplying. 30 times 1 is 30. This will be a times tan of 35, and we realize that's a decimal number. So to solve for a, we simply divide by tan of 35, both sides of course. 35 tan, let's put that in front, Here, of course, they cancel out, and our answer will be found when we calculate 30 over tan of 35. When you do that, you get a value of about 42.8. Justify that on your calculator. And then we could find c in a similar fashion, but notice now we have both of the legs of a right triangle, so we could employ the Pythagorean theorem. 30 squared plus 42.8 squared must equal c squared. And I'll leave the calculation there to you. I came up with a value of 52.3, so you can check that out for yourself. And that's how you do these first couple of problems.